In this video, we're going to explore what is called the Pythagorean Theorem. And this is a really important sort of theorem for doing work in geometry, especially with right-angled triangles. And that's the very, very first thing that we need to make clear about this particular idea in geometry, is that it only works with right angles, or right-angled triangles. Only works with right triangles. And the idea of this theorem came about long time ago from this ancient Greek guy named Pythagoras. And after doing a bunch of work and looking for patterns amongst triangles, he noticed something that was rather interesting. The first thing we need to know is we need to know some words that go with triangles. And so in a right angle triangle, you'll always have these, you have these two shorter sides that are sort of connected by the right angle, and those are called legs. So here's one leg, and here is the other leg. And then the third side, which is always the longest and is opposite the right angle, is referred to as the hypotenuse. And so you will hear these words being used an awful lot. We have legs and we have the hypotenuse. Now, the Pythagorean theory, instead of using the words legs and hypotenuse, just uses letters. And so the letters that we use, one of the legs is going to be referred to as side A. The other leg will be referred to as side B. And the hypotenuse will be referred to as side C. And so C is always the hypotenuse, and really A and B can kind of interchange. It doesn't really matter what they are. So based on Pythagoras' observations, he created this theorem, which basically, as we stated, said that found a connection between the lengths of the legs and the length of the hypotenuse. And here is what it was in math that he sort of discovered. That A squared, so the length of one leg squared, plus B squared, the length of the other leg squared, it's always going to be equal to C squared, or the length of the hypotenuse squared. This is the Pythagorean theorem. The first purpose of using the Pythagorean theory is to find out whether a triangle is actually a right angle triangle. Now, in this case here, I've got that little right angle symbol drawn in, so we can pretty much assume that it is, but let's actually test it by using the lengths of the sides. And so what I'm going to do is I'm going to use a ruler here, and I'm going to measure each of the sides. So if I measure the first leg, or leg B in this case, I find that it is 30 millimeters, or 3 centimeters long, so I'm just going to label that as 3 centimeters. And I'm just going to quickly rotate this to get the other leg, and I see that the other leg is 40 millimeters, or 4 centimeters. 4 centimeters. And I'm going to measure the final leg, or sorry, the hypotenuse really, which in this case is 50 millimeters, or 5 centimeters. So what I have here now are the lengths of the three sides of my triangle, and I'm actually going to confirm that this is a right angle triangle by using the Pythagorean theory. So I'm going to substitute in my values and see what I get here. Essentially, I'm doing a check step. The length of A, based on my diagram, is 4 squared, plus B is 3 squared, and C is 5 squared. And so let's kind of work that out. 4 squared is 16, plus 3 squared is 9, equals 25. I guess I don't need that equal sign here. And 16 plus 9 is 25, and that equals 25. So yes, our check step works, which in this case confirms that yes, this is a right triangle. If it was not a right triangle, those two sides would not equal one another. Now, the second thing we can do with the Pythagorean theory is use it to find the length of a missing piece of our triangle if we have a right angle triangle. So the first thing I'm going to do is I'm going to look down here and confirm that yes, this is in fact a right angled triangle. So if it's not a right angle triangle, this doesn't work. Now I'm going to just substitute in the values here. And so I'm going to always start with using my formula. A squared plus b squared equals c squared. And now I'm just going to substitute in the values I have. Now, c is always the hypotenuse, so that one's kind of locked in. But a and b being the two legs, it doesn't matter which one is a and which one is b. I usually just make the shorter one a and the longer one b, just to make it easy for myself, but I don't have to do that. So let's work this out. A I'm going to say is 9 squared plus 13 squared equals c squared. And so I'm going to kind of work this out. 9 squared is 81 plus 13 squared is 169. And it's helpful to kind of learn some of these square numbers, especially the ones from 1 squared all the way up to 20 squared, and that can make your life a little bit easier. 81 plus 169, that's kind of 80 plus 170 is 250 equals c squared. Now here's where I need to remember that the inverse operation of squaring is square rooting. So to show that, I'm going to actually take the square root of the left and the square root of the right. So the square root of c squared is c, and the square root of 250 is, well, I'm not too sure, so I'm going to pull out a calculator to help me with that. And let's grab that calculator. There it is. And so I'm going to find the square root. There it is. The square root of 250, and then hit the square root button. And it gives me 15.81138888. Okay, well, I don't need all those decimal places, so I'm just going to round to the nearest tenth. 15.8 centimeters. And a real quick way to check is, remember, the hypotenuse is always going to be the longest side. So if this is longer than those two legs, then that's a pretty good indication that you've probably done this correctly. Now, sometimes it's not the length of the hypotenuse we're trying to find, but it's the length of one of the legs. So our second example here shows us that we have a right angle triangle, and we can see that based on, once again, we've got the right angle kind of square there, and we've got a hypotenuse of 18, and we know this is the hypotenuse because it's opposite the right angle triangle, the right angle. And we've got two legs, a leg that has a length of 12 and a leg that has an unknown length. So we're going to use the Pythagorean theory again, but this time to find the length of one of the legs. So remember the Pythagorean theory, a squared plus b squared equals c squared. And so let's substitute in our values again. So I've got for a squared, I've got a, I don't know what it is, plus b squared, 12 squared equals c squared, 18 squared. Remember, do some simplifying before I start solving. So a squared stays the same. 12 squared is 144. And 18 squared, I believe, is 324. So now I'm into my equation solving mode. And you can see I get a couple steps this time. The first thing I need to do to get the variable by itself is to subtract 144 from both sides. And so I get a squared equals 180. And now, because I'm trying to undo a square, I will use the square root on the left and square root on the right. So the square root cancels out the square, leaving me with an a. And to find the square root of 180, I'll bring up my calculator again, and I'll just type that in. 180 square root is 13.4. 13.4. And so you can kind of see here that a quick sort of concept check can kind of let us know that we've probably done this right, in the fact that we would expect the length of the leg that we're trying to find to be less than that of the hypotenuse. So this is how we can use the Pythagorean theory to find the length of a missing leg.